topic for vectors. So first, what is a vector? Well, it's a quantity that has both magnitude and direction. Now, magnitude is a fancy term for size or length of vector. And directions means which way is the vector pointing, or what angle does it make with the x-axis. We use an arrow or ray to represent a vector, where the length of the arrow is its magnitude, and which way it's pointing is its direction. Now look what happens when I do this. Alright, so now it's a direct copy of that vector, same magnitude, same direction. But if I stretch it out like this, now the magnitude of this one is different, right? It's a lot longer than the last one. So different magnitude, same direction still. Similarly, let me copy this vector over there. And now let me rotate that one. So now these two vectors, this one and this one, have the same magnitude, the exact same copy, so the exact same length, but this one has a different direction. Alright, so same magnitude, different direction. Now let's talk about vector notation and component form of a vector. So here's our vector. You kind of want to think about it like an arrow. Where here's the tail, and here's the tip. So when you write a vector, you can write using the two endpoints right there. So where you start is the first letter you put down, and then where you end the second letter. So this would be vector OA. You could also name this vector using the lowercase letter right there. So you could call this lowercase a with a little arrow on top. Your books can use the bold lettering right here. So they do the same thing, but they'll use it in bold, which is way too much work for us. So we just either use lowercase a or use the endpoints. Remember, starting at the where you start. We'll talk about this more later. But magnitude is symbolized with the absolute value sign that you see here. So if you see this, it does not mean absolute value. It means find the magnitude of that vector. So I can't stress that enough. That means find the magnitude. Now component form of a vector. Component form of a vector just means the vector that starts at the origin. So vectors can start anywhere. Right? That could be anything. So you have a vector that looks like that. You have a vector that goes the opposite direction, actually, if you want. You have a vector that starts here, goes that way. But when you have a vector that starts at the origin O here, and goes to some point A over there, it's a vector in component form. And we like those. Those are our favorites. That's vector OA or vector A. So this is component form. And this is not. Now let's talk about how to write a vector in component form. So here's the point I give you, 4, 2. Alright, so let's draw it out. So there's point B, 4, 2. Now remember, if I wanted a component form, that means I'm going from the origin to that point right there. So I'm going from OB, right? From O right there, the origin, which is also known as the initial point. Or I could say tail. To the terminal point, B right here. Also known as the tip. Right, and I get to the point OB, the vector OB, or simply just B. Right now, if you let's say if you want to write as a vector, it's actually very simple. In most books, you just do this. You'd write the pointing vectors. Use the pointing brackets. So the point's 4, 2. And that's a vector going from the origin to point B, 4, 2. That's how you write it. Or you could write it in the cool, slick IB way, which is right where they write it vertically. So they put the 4 up here, the x value up there, and the y value down here. So this is the way you're going to see in your book all the time. There's actually one more way to write it. It's called unit vector form. That's where you take the x value and you put an I next to it, and then you know that that's the x value. And then you put a y value. You take the y value and you put the j next to it, and let you know that it's the y value. So that's the x value, and that's the y value. Your book will use these two values right here interchangeably. Let's work on this example here. So now here I'm given a vector. Notice it's not a point, it's a vector, it's in the vertical form. And let's just draw it in component form. So let's go to the point -3, 5, right? So that's the x value -3, and that's the y value 5. So we're going to go to that point. So -3, 5 right there. Now remember, it's in component form. That means you start at the origin and you go toward that point. And that's vector C. That's how easy it is. Now remember, they could also write it like this: -3i plus 5j. That's if they want to write it in unit vector form. But that's it. Okay, next let's do a type problem you're going to see a lot in this class. So, given 2 points, find the vector in component form. So in this case, I gave you these 2 points, point A, A2. So let's figure it. Let's get that, A2. And then point B, 10, 7. So 10, 7 around there. So that's B. So now, what this notation here means is that you're going from A towards B. So you're going from A towards B. Right, so you start at the first point here, and you're going toward the other points. So from A towards B. Now the way you find this vector in component form is actually very simple. The trick here is tip minus tail. So if you do tip minus tail, remember that the tip is right here, the arrowhead is. So that's B minus the tail, which is right here, A. And all you do is get the corresponding parts. So B is the point 10, 7. A is the point 8, 2. And then you just subtract the corresponding parts. So 10 minus 8 is 2. 7 minus 2 is 5. And that's component form of the vector AB. And what does that mean? Well, if you go over here and draw component form, so remember the way you draw it, you go from the origin to the point 2, 5. So 2, 5. Origin to that point. Now if you look at that, they're the same magnitude, the same direction, just that one's at the origin. That's in component form. Now let's quickly do BA right here. So right, the same idea, tip minus tail. So in this case, my tip's going to be A. So this is going to be A minus B. Right? A is 8, 2. B is 10, 7. Subtract the corresponding parts. So 8 minus 10 is negative 2. 2 minus 7 is negative 5. And now you have the vector BA. So hopefully you notice that these two, if you notice right here, AB is 2, 5, BA is negative 2, negative 5. And that's always true. So if you have a vector AB and you want to find its switch BA, all you have to do is negate the answer you just got. And that's because the vector BA is the vector that starts from B and goes toward A. Right? So it's going the opposite direction, so it's negative. That's how you find a vector and component. Okay, before we move on, let's do one more quick example. So here, I give him the three-dimensional point B, 1, 3, 2, and the three-dimensional point D, 5, negative 2, 3. Now don't get freaked out the fact that there's 3 coordinate points here. It's the same thing. That's your X, that's your Y, and that is your Z. And you do everything the exact same way. So right here, if I want to find the vector DB, remember tip minus tail. So that's going to be, we're going from D toward B, so my tip is B. So it's going to be B minus D. So that's going to be 1, 2, 3 minus D, which is 5, negative 2, 3. Subtract the corresponding parts, so 1 minus 5 is negative 4. 2 minus negative 2, double negative makes a positive, so 4. And 3 minus 3 is 0. And that is the vector DB. Now if I want the vector BD, right, I could do D minus B, but I could also just negate the answer I just got, right, because it's going in the opposite direction. So this could be 4, negative 4, 0. And that equals the vector BD. There you go. Now let's talk about how to find the magnitude of a vector. So let's take our vector we did a little earlier. Vector AB equals 2, 5. Right, so remember that's the vector 2, 5, 1, 2, 3, 4, 5. So like that. Now remember, magnitude means how long is a vector. So I'm trying to figure out how long that vector is. Right? So if you notice, it's just a right triangle. So all you do is Pythagorean theorem. And that's where this vector formula comes from right here. Now that's a formula that, again, that's in your formula sheet, so you get to use on anything for this class. Homework, quizzes, tests, anything. Now don't get freaked out that we only have 2 components and they have 3. When you only have 2, just ignore the third term. When you have all 3, like we have right here, then you just use them all. So that's pretty much it. Do you want to find the magnitude vector? Again, that's the symbol for magnitude, not absolute value. Don't make me hurt you. So all you do is use the formula. So the first term squared plus the second term squared. Square root both of it, so you get 4 plus 25. And remember guys, it's not 2 plus 5 again. Order of operations, do these two first. So square root of 29 is the magnitude of that one. Which again, that means that's how long that vector is right there. That length of vector is about like 5 point something. So there you go. Now this is the one down here. Right, so same idea, I'm trying to find the magnitude of this one. So I'm just going to use the formula that's over there. So it's the first term squared plus the second term squared plus the third term squared and then the square root of all that. So in that case that would be 2 squared plus negative 1 squared plus 4 squared. So you're going to get 4. Now remember guys, anytime you square anything it becomes positive. So plus 1 plus 16. That gives you radical 21. And that's it. That's the magnitude of that one. So that's how you find magnitude. Super simple. Okay, so now we're going to talk about unit vectors. Unit vectors is kind of exactly what it means. It's a vector with unit 1, so the magnitude 1. So there's no real formula of finding this in your formula sheet, but the unofficial one is this. If you want to find a unit vector, you get your vector and you divide it by its magnitude. Right? So if a vector has a magnitude of 5, you divide by its magnitude of 5 and you get a magnitude of 1. So let's do an example. Let's go back to our favorite. AB is 5, 2. Let's find a unit vector in that direction. So all you gotta do is follow this formula right here. So that means in this case my vector is AB. I'm going to divide it by its magnitude, the magnitude of AB. Now we actually did this earlier, right? The magnitude of AB, we just used that formula. So we did 5 squared plus 2 squared. You got radical 25 plus 4, or radical 29. So if we want to find the magnitude, all we're going to do is this. We're going to get our vector, 5, 2, and divide by rad 29. That doesn't look really good. Let me write it like this. This is a little cleaner. You distribute to both of them. That distributes in. And you get 5 over radical 29 and 2 over radical 29. And that's a unit vector in that direction. Now, when you do a unit vector, you generally want to actually write in that notation of the unit vector. So you want to write it in the ij notation. So 5 over radical 29, I plus 2 over radical 29, j. And there you go. So that's how you write a unit vector in the direction of a vector. All you do is to get the vector itself and divide by its magnitude. Let me scroll down a bit. So again, just a little more information on the whole ij thing. It's the exact same thing. You could write a vector in this form or in unit vector form, which is just for the x value you put the I, and for the y value you put the j. Because I represents a unit vector in the x direction and j represents a unit vector in the y direction. So again, if I just give you something that's like this, you can write it that way, or if you want, you can write it like this. Same idea. And finally, let's do some basic vector operations. So here's two vectors, vector A and vector B. If I want to add two vectors, A and B, all you do is add the corresponding parts. So A is 5, 1, B is 3, 2. add the corresponding parts. So you get 5 plus 3 is 8. 1 plus 2 is 3. There you go. That's a vector AB. And if you want 2A minus B, very simple. You just kind of follow what it says. So 2 times A minus B. So 2 times A, all you do is distribute that. We call that you distribute that number to both of those terms. So you're going to get 10, 2 minus 3, 2. Then subtract corresponding parts. So 10 minus 3 is 7. 2 minus 2 is 0. And that's it. Now they could also set this up in unit vector form. So instead of being like in the nice cool vertical form, they could be like 2 times, let's say, 5i plus j minus b, which would be 3i plus 2j, right? So the same concept, you do the exact same, which is written in a different form. So you get 2j, distribute that negative both of them, negative 3i minus 2i, add up like terms, 7i, these cancel out, so you just get 7i actually, which is the exact same thing as this. So that's it in component form and in vector notation and unit vector notation form.